Hello and welcome to Grade 4 PD focused on exploring and classifying shapes.
I'm Joe Ratasky.
And I am Emily DeVizio. Thanks for being with us today. Your first task, you can access this document through the QR scan code link there or through the link that you see provided on the slide. That will download a document that you're going to use on the next slide when you look at 7 stations, showing how different shapes were sorted based on attributes.
Go ahead and pause the video now on this slide so you can see the stations. We'll see you in a couple minutes.
Some of you may be wondering, well, how are we supposed to classify those particular shapes that we just sorted? That's the importance here, is that students are just exploring and they are able to classify shapes based upon their understanding of lines, angles, and the ability to measure angles, which they did address in the previous unit.
Well, I think just letting kids look at those and see what they come up with too is a good informal assessment of what they know or don't know, or just their line of thinking.
Absolutely, and where you need to spend your time building their understanding.
We did introduce this idea of concept cards with angles. So if you watch the angles video, this might look familiar. But if you did not, just so you know, using a concept card basically shows students an example of what that concept is and a non-example without giving them a definition. So it's great because the students will look at these things that are examples of polygons and these that are not, and then you ask them to come up with their own explanation and definition of it.
And we're getting ready to talk about modeling triangles and quadrilaterals, and this is a great tool to support that. So here you could see, before we move into actually talking about quadrilaterals and triangles, that we want to spend some time with our students modeling points, lines, line segments, and rays, because this is one way for our students to classify those polygons as well as angles that they've learned in the past.
And reading this, you kind of see the difference of course, we want to have those concrete models that they're able to do with their polygons, but points, lines, segments, some of those are kind of difficult to concretely model, so they would have to do drawings with those.
A great real-world example of modeling parallel and perpendicular lines and line segments. You could have students using sticks, 2 sticks, or other representations, might be spaghetti, could be anything you want, straws, for students to be able to recognize pairs of parallel sides within those shapes, especially in the quadrilaterals.
It just helps them to extend those line segments into lines, so they would see if those lines would eventually ever cross or not.
We're going to spend a lot of time today, or most of our time today, talking about geometric attributes and properties of triangles and quadrilaterals specifically. One of the big things that we wanted to point out is similar to what you did in that first task. We want to provide our students with activities and tasks that provide a context for our students to be able to explore those attributes and derive their own definition and understanding. Something important to keep in mind is that when we are talking about a property, that is an attribute that applies to all of those shapes in a certain class. We've provided an example on this slide that you can look at your leisure when you're teaching this concept.
But yeah, it's so important that our students are using those attributes to define their shapes, not just the names, not just what they look like, because they're going to just look and see, oh, a rectangle looks different than a square. So they're different shapes, but really, if you look at their attributes, they're better defining them as having 4 right angles.
Mm-hmm.
So for all the kids who struggle with seeing that a square is a special type of rectangle, it's because they're focusing on looks and not attributes.
This slide just simply talks about the different ways that we could model triangles so that our students do start to explore triangles based on different attributes. We want to make sure that we're not just exposing them to the equilateral triangle or one example of a triangle. We want to make sure that they are classifying them by their sides as well as by their angles.
And moving into doing the same thing with your quadrilaterals, again, focusing on attributes. When we're talking about all rhombuses or all rhombi, what do they have in common? What are their attributes?
And Joe, we talked earlier about those concept cards. Like here's an example that you could use riddles. But again, when you're modeling those triangles and those quadrilaterals, the concept cards is a great tool for you to use so that students can share examples and non-examples and derive their own attributes. We've talked a little bit about the modeling of triangles and quadrilaterals, but students are also going to experience naming and sorting those triangles. So once they've looked at the different attributes, now they can sort them by like attributes or by names. You see reference down there, a Venn diagram is a good tool to use for that, and we will share a slide on the subsequent slide of a Venn diagram example that you can use with your students. But again, same thing with quadrilaterals. We want to make sure that students are sorting them by common attributes.
And the hierarchy that you see here of quadrilaterals can also be helpful so that students recognize that, say, when you're looking at the square, it has the attributes of all of those classifications above it, or rectangle looking above.
So here's the example I referenced earlier that Venn diagrams is a great tool for us to use, and we have provided a link there for you for students to be able to sort those shapes based upon the attributes that they have discovered.
And you may notice that we see one of the attributes in our example is, do these shapes have right angles or not? So in third grade, students were informally looking at right angles, but really we were just calling them square angles. Now in fourth grade, now that we know how our angles are measured and we can classify them as acute, right, obtuse, etc., now we're really using that correct terminology of right angle. And I really like the Venn diagrams because kids can kind of sort how they think. They can come up with their own attributes, move them around. You could do a guessing game where maybe you sort one way, I sort another, and then we go and try and guess. Try and guess what the attributes that were used.
So again, as we do on all of the slides in the drop-in PD, the very last slide talks about the different ways of thinking for our students, concrete, representational, abstract. I think it's important to point out again here that we can go back and forth along all these different ways of thinking. But what's important is that we do start at the concrete level, especially this is the first time that the students are introduced with classifying those triangles and quadrilaterals, and then again, moving to the more abstract representation.
We're going to quickly look at our transition into Florida's best standards to look at maybe any differences.
Here we could see that what we've talked about today that are currently fourth grade benchmarks, the grade levels that they will be moving to with the new best standards. So for example, in fourth grade this year with the math standards, we're talking about describing and drawing points, lines, line segments, rays, etc. That will be moving to third grade with the best benchmarks.
And we see a lot of that classification of triangles and quadrilaterals moves from fourth grade into fifth grade with the best.
I think in fourth grade with the best standards, they're going to be spending a lot of time focusing on angles.
Yes.
So here, just at your own leisure, as we said before, go ahead and take some time to read over these overall changes that you will be seeing when we enter into focusing on the best standards next year.
That last bullet's important. With best, we have actually defined now that trapezoids are having at least one pair of parallel sides. So that's going to change our hierarchy of quadrilaterals. By saying at least one pair, it means that now any rectangle is also a trapezoid because they have two, which is at least one. It's two.
Very different than having one, right?
Right. So with maths, it was never defined. We kind of left it open. It's nice now that with best, we know we have one definition that we're going to use.
That is all we have for you today. Thank you for joining us, and we look forward to seeing you at our next Math Dive in 5.
I don't know where the song is.